from what we see from the problem, we know that the airplane is going to be flying at 500 kilometers per hour in the direction of north 40 degrees east. And the wind acting against it, because it hates the airplane, is going at 60 kilometers per hour, is going north 30 degrees west. So from these two problems, it's kind of hard to know the bearings. So I'm just going to draw them out. As you can see, you just start from north and then you go 40 degrees east. You just do it as it says. Sorry, I messed up there. And same thing. You start at north and then you go 30 degrees west. Exactly as you would read it. Now I'm going to combine these two vectors, and I'm going to start with the airplane. So you can see it has I'm going to make it relatively long. I'll label it as 500 kilometers per hour, and show that that's due north. And then I'll combine it with the wind, which is relatively small, at 60 kilometers per hour. Label the angles. 40 degrees and 30 degrees. Bada bing, bada boom. Okay. So now I'm going to use the head to tail method, and I'll go from both directions, and I'll show you why in a little bit. So I'm going to draw it there, and they both meet in the same place. As you can see, they create a parallelogram. And I'm going to split the parallelogram in half and connect the 2 points, head to tail. Yes, both sides, or opposite sides I would say, my bad, are congruent, and angles are also congruent, because that is part of the definition of a parallelogram. So if it's 70 and 70, you know, 360 minus 70, I dropped my eraser there, 360 minus 70 times 2 is 220 divided by 2 is 110. So there's going to be 110 degrees in this corner right here, right there. And if we can see from what we know, that this is going to be a side angle side proof. And with that proof, we can use the law of cosines to determine that side, the hypotenuse of the triangle. I guess you could call it hypotenuse. Anyways, that line that splits the parallelogram in half. That's what we're trying to solve for, because that is the magnitude of the resultant vector. So that's the law of cosines, and I'm going to label the triangle so that we can just plug in the numbers and apply this law of cosines. So this side would be A, and the angle opposite is going to be capital A. I'll make 500B and 60C. So capital B opposite of side B, and capital C opposite of side C. Now we can just plug in our values. A squared equals 500 squared plus 60 squared minus 2 times 500 times 60 times cosine of, as you can see, A is 110, so times cosine of 110. Okay, now I'll pull out my calculator and show you. As you can see, I'm just plugging in the values, that's all I'm doing. Kind of tired today, but yep, there it is. So A squared equals 274,121. Oh, I'm sorry, I put the comma in the wrong place. Whatever, we'll just ignore it. But we found that angle, or not the angle, blah. I'm messing up my words. The magnitude of this vector is going to be 523.6. Now, what are we going to do to solve for direction? Right? Well, if we look at what we drew earlier, we can see that from due north to 500 to that 500 vector, it's going to be 40 degrees. So if we do 40 degrees minus angle C, we will get from due north the direction of the vector we just solved. And for this, we need the law of sines. So law of sines, and we know sine A over A. We don't know sine C, but we do know C. So we can solve for angle C using these values. So sine of 110 over 523.57. Sorry, I'm going to erase that. Should be rounded to there. There you go. Equals sine of C, because we don't know C, that's what we're solving for, over 60. So now I will just solve. So sine times 60 over 557, sine of C, and then I'll just do inverse sine the whole thing. I'm going to rewrite this out, that way it looks better. Sine -1, sine C. Those cancel out, we're just left with angle C. So let me put that in my calculator. This is where we would be playing the Family Feud interlude music. And there. So it comes out to be 6.2 degrees. But that is not the direction. As you can see, remember the direction is 40 minus that angle, so I'm going to replace that with 6.2, and that comes out to be, let's refer to the calculator, 33.8 degrees, and if we round that, it's 34 degrees. So there we have it. Our magnitude is 523.57, and our direction is N 34E.